So I started playing around with this Emco Turret, and I made some ladder logic so that it would be run from LinuxCNC, and I thought maybe you guys would like to see this. So this is a Emco Turret from a Compact 5 CNC, and I'm kind of setting it up the way that the original control set it up. It's one output. I'm using one pin from the printer port, running a transistor, which is running a relay here. All this electronics is from a different project. It's really just this transistor and relay. It's hooked to pin 1 of the printer port, and it's really quite simple. I'm using 2 poles from this relay, so they're set up so one way it's reversed through the resistor and the other way it's full voltage to the motor here. And so the way it works is when it's off, or logic 0, it's running the motor into this pawl, but through the resistor, so this motor hardly gets warm. It actually is supposed to have lower resistance, like that's 100 ohms. It's supposed to be around 33 ohms. So it isn't pushing it quite as hard, and this motor is like cold, but it's working. It's working for testing. So I can show you here kind of what's going on here. I'm gonna switch views here. So I'm actually gonna launch. Well, here first I want to set up classicladder on this config, and your LinuxCNC documentation is awesome. You go to linuxcnc.org/docs and then pick which version of LinuxCNC you're using. The documentation is pretty darn good. So these are to get classicladder started within LinuxCNC within a certain config. You need to add some HAL, a couple HAL lines. One is to load classicladder, and then the other is to add the classicladder function to LinuxCNC. Initially, anyway. There's a lot of other stuff we're going to have to do, but this will get us so we can start editing ladder. So we're going to do this, and then we need to have a file that the ladder is going to use. So that's done with this load user part. So I'm going to add that line. I'm adding to the bottom of the HAL file so we can kind of keep it all in one place. I'm going to rename this to Turret. Alright, I'm going to save this. Oh, we also we don't want it to load the classicladder GUI every time, but we can load it through LinuxCNC. So we just want to add, oh, that was cool. Undo is your friend. So --no GUI just makes it so when you launch LinuxCNC, it doesn't automatically launch the classicladder GUI. So, alright, let's see if this works. So we're going to launch Servo Emco. You can see, I don't know if you could hear that, but it must have twiddled the bit for a second, because this moved. I mean, I don't know if it really moved, but you could hear it doing something. So okay, we have LinuxCNC started, so we should be able to start ladder. Well, first let's show you that the bit works. So I really like the HAL command. So this loads the HAL command line, which allows you to just fiddle around in HAL. So if I look at the printer port pins, so here are all the pins, and pin 1 isn't hooked to anything. So I'm gonna set pin 1 to true. So set P Parallel port 0 pin 00, oh, 01, sorry, to true. Should make this turn clockwise, and it does. And then when we stop it, when we set the pin to false, well, here, let's switch this so you can get a close-up view. That's pretty cool. Alright, so if I stop this now, if I set this to false, it'll stop and then run itself into the PAL. Let me run this further so you can... So that's the whole technology of this thing. So what we need to do is set up some ladder to make it so that when LinuxCNC calls, say, tool 2, it knows where to go. Can you see that? When it calls tool 2 or tool 3 or tool 4 or tool 5, it knows which way to go, or where to go to get to it, because it only goes one direction. So what are we going to do? That's a good question. Well, let's initially just bring up classicladder so we can kind of take a look at it. So this is the ladder. Let's move some stuff around here. And try to put that down there. We can move this over to here. And maybe move this down. Maybe make it a little longer. I just don't want to cover anything. So then we have the editor, which is how we edit these. I'm gonna add I like to have 2 to begin with. I don't know why, I'm just weird that way. So let's play with ladder. Did this? Okay. I don't know if you saw it, but I think it said like could not load project or something. That's because the file didn't exist. So once I hit save, it saved it as the file that I told it to in the HAL file here. And now there should be a turret in the LinuxCNC config directory, a turret.clp. So far so good. So let's look at this. And I'm going to show you does this do both? Oh, there we go. Oh my gosh. Alright. So there's some, this is going to be like a high level, quick kind of tutorial of it. There are these are bits. So ones and zeros. These are internal to classicladder. These are ones that you'd use that you didn't care you're doing something with within classicladder. These are inputs to classicladder, and then these are outputs. These are what you'd normally call coils, I guess, in ladder. I'm not a big ladder person. I had it once in college, and now I use LinuxCNC's ladder, so I don't know how close this is to other ladder, and then these are actual words. These are internal words, the W's, the straight W's, and then there's also so IWs, which are input words, and then QWs, I think, are outputs, which are the coils. And there's other ones too. Whoops. Why didn't this change? Ah, okay. So these are word inputs, S32s, and these are outputs. Not that we're going to use an output on this, but we don't really need to at this point, I don't think, but yeah, we might at some future point. So let's create a rung here. I don't know if that's the right word. That turns this on. That turns the turret on and off. So we're gonna we click on which section. I don't know what this is called. This is, I'm almost thinking this is a rung, and then I don't know what they call the actual whatever across here, but we're going to modify it, and then we're going to put, this is like a switch, let's say, but we're going to make this an internal bit. Oops, capitals. And then hit apply, because if you don't hit apply, it'll go back to what it was before, and it can kind of be annoying. I'm sure I'm going to do that. Oops. And then we're going to have an output Q0. Q0s are outputs. Q's are outputs, I should say. And alright. So now we have, if we click bit here, you can see that turns on. But it's not doing anything because we have to connect this bit from classic ladder to the parallel port, and we'll do that in this HAL command line. So I'm going to use a net command, which kind of is a way to hook pins to one another within HAL. So net, and then the first thing is the signal, or what else would you call it? It's what's connecting the pins together. So it's like the wire. So let's call this turret control. And we're going to connect it to the parallel port. 0, pin out. Well, tab completes your friend too. Oh, 01 out. And we're going to connect this to the classic ladder. Let's see what's here. Out 0, 0. Alright, so because that didn't err, and we want this to be part of HAL, we're going to copy this line into the HAL file. And like I say, we're going to do it all down here at the end, just so we have it all together. So now we've connected the parallel port to the classic ladder. So now, if we click this here, hey, look at that. We have a turret that's running. We can turn it off. We can turn it on. And we can turn it off. Alright. So now what? Well, because this is kind of, we have no feedback, we're going to have to use timers to control this, at least initially. So what do we have for timers? Let's look at the ladder. So that's the section display. So I think these are sections, and then each thing across there is a rung. I don't know. Alright, so we have a few timers here, but I've looked at this before. So these the timers and monostables are all supposed to be depreciated from depreciated, and now the IEC timers are being used. So we're going to use an IEC timer. Input, output contact, and then we have a bunch of different settings, it looks like. T on, T off, and TP. T on, after countdown is done, long time is true, the output will be true. No. When the timer input is true, set output true, the output is no. When timer input is pulse true or held true, the timer sets the output to true until the timer counts down. I think that's what we did. Yeah, it's a one shot. Okay, so we need an IEC timer. Okay, so if we go, we're going to put a timer in here. So we're going to modify this ladder. We're going to put a TM. See if you mouse over this timer IEC block. We're going to put it here. Look at that. And we can have it in seconds, minutes, or hundreds of milliseconds. I think we want hundreds of milliseconds. And let's set it to 10, which 10 times 100 milliseconds would be a second. Let's see what that does. Let's go to the bits. We're going to turn this on. Well, that was weird. Oh, Did we change this timer type? I don't think we did. So it's T on. We want it to be TP. Oh, let's try it. Alright. So if you see this, I'll change this view quick. You'll see that it doesn't, 1 second isn't enough. Alright, so let's make it longer. Let's make it 2 seconds, or 100 milliseconds. What does that look like? That's pretty good. We probably want a little fudge there, so why don't we do 2.1 and see what that looks like. 2.1 seconds, which would be 2100 milliseconds. That's confusing. What does that look like? Yeah, we'll give that a try. We can always make it longer. Do we want to make it longer? Oh, we can give it a little more fudge. Let's give it 22, which is 2.2 seconds. What does that look like? Yeah. Let's give that a try. So if it slows down a little bit or speeds up a little bit, we should be good. Alright, so let's go 2. Let's go like we were going to go to 1 to 3 on the tools. So we'll double this and see what it looks like. So 22, 44. And this is what we're going to run into here, because I already kind of know what's going to happen. First one. You see how much further that went? I'll show you. So you have a... oh, you are in the close-up view. So you see how much further that overshot? So there's actually going to be 2 separate times. There's going to be the amount of time it takes to go the first tool position, and then every tool position after that is going to be shorter. So if we did, so this is 2, and you can see how much further that overshot. If we go 3, which would be 22, 44, 66. You'll see how it's just adding up. So if we went a full rotation, that would be really off. So 1, 2, 3. See that? So we have to figure out what the second time delay is. So let's figure that out. So let's just go 2 for now. And so 1 was 22, so 44 was too much. Let's try 35. Oh, not quite enough. Alright, so let's try 40. Well, that looks pretty good. Alright, so let's go a full rotation and see how that works. So let's do a little math. I'm doing a little math here. So it would be, so we figured, what was this? 40. So 22 minus 40. So it's 1.8 seconds for everyone after that. Let's go a full 6 positions, which would be a whole rotation, and see how it ends up. Because if it's within the same amount, you know, overshot, will be good. So 18 times 5 plus 22. That's 112. So let's see if we do a whole rotation, 112, with it having a decent amount of overshoot, and we'll go from there. Ready? This should go a whole rotation. So watch. That looks pretty good. All right, so the first one is 22 or 2.2 seconds, and everyone after that is 1.8 seconds. Gonna remember that? All right, so that looks pretty good. So let's switch back here so you can see what I'm doing. All right, so now what? Well, let's think about this. Now, I've kind of thought about this already, and I've played around with it a little bit. So this may look kind of quick, well, painfully quick maybe, but it's only because I've kind of already thought through this once already and kind of had it working. But I thought I'd show kind of my thought process, and granted, this might not be the perfect way to do it, but this is the way I thought of doing it, being that there's no feedback on this ladder. So what are we gonna do? Well, let's start thinking ahead. So we're gonna have to have, I think we're gonna have to have a variable within ladder that keeps track of what tool it thinks it's at. So I think we're gonna use W0, but as you can see, W0 starts as 0, and for simplicity we're going to have 6 tools. So we're going to have LinuxCNC is going to send 1 through 6 as the tool numbers. So I think we need W0 to start at 1. So we're going to kind of have to initialize it. So that's what we'll do. I'll put this up at the top. And what I'm going to have is a compare. Whoops. Oh my gosh. And then you have to get used to how this works, because I swear, let's get rid of this. Sometimes I have trouble with this GUI. I don't know why can't I put this over here? I think I'm going a little crazy. Well, it doesn't matter. And then we're going to set an assignment. We're going to set W0 to 1 if it isn't between 1 and 6. So we're going to go into comparison and say percent W0 is if percent W0 is less than 1, and so let's look at how we do an and in a compare. So an and is a straight up and down, or I mean, sorry, we want an or is straight up and down, and you can see here they do it by putting a comma in the symbol. Note the comma separating the two groups of comparisons. Okay, got that? So we're going to do comma straight line, which is or, percent W0 is greater than 6. Not that I think it will happen that way. So that's the comparison, and the assignment is going to be percent W0 equals 1. So this will be like the initialization. And thinking ahead again is we're going to have to have a way to manually jog this. So I think we'll also do that. So if you click within LinuxCNC, it'll probably set up like a little side panel that allows you to initially set this when you first turn the lathe on, because it doesn't know where it is. It might be at tool 1 here, but there's no guarantee of that. So we have to have a way of, let's say it's setting at tool 6, we can jog it ahead to tool 1 and then tell LinuxCNC, okay, we're set at tool 1. So that's my thought. So now if we look at this, you see W0 is 0. Once I hit OK here, that should switch to 1. And it does. So now we've initialized this internal word here to 1. Alright, so let's say we're going to use B0 as the jog. Alright, so we also want B0 to reset the assignment to 0. So let's add that. This will be for futureness, because why can't I swear this editor sometimes acts really goofy. Huh, so can I do it down here? Okay. Don't ask me. You're seeing it warts and all. So we're going to get rid of this, and we're going to say this is percent B0. And we want to make sure we apply that. Alright, so every time we jog this, and let's change this back to so it's one rotation or one tool position. Hopefully you're hearing all this. Alright, so we're gonna hit OK. Oops. We have that bit set. Alright. I don't know why that didn't work. Anyway, so let's change this one back to what was it? 22? 2.2 seconds. Alright, so now if we do this, it goes one position ahead. Alright, so we may have to do more logic, but that'll be a good start. I swear. Let's see here. I don't like that that's down one. It's not going to let me put anything except for there. Alright, it is what it is. Alright, so now what? So we're going to have to send ladder the tool number, right? So initially we'll set up a signal so that we can just set it manually within HAL so we can play around with it. So we're going to do a next tool. We're going to connect that to W0, IW0. So classicladder S32 in 00. Alright, so we're going to also put this into HAL, the HAL file, so that we kind of don't get surprised when we forget something. So this isn't really hooked to anything. This just allows us to now do this. I'll show you here. So we just hooked up to this W0. So if I say net, or so sets, which is set signal next tool. I forgot the extra T. Oh, that's efficient. 1. So now you see that IW0 is 1. So that's what we'll use to send classic ladder the tool number. So now what are we going to do? So we'll have to set up a few compares. So we're going to compare the W0 to the IW0 and see if one's higher or lower than the other to figure out if we're going to be moving, how we're going to be moving. Does that make sense? So let's do that. So what we're going to do is make another comparison. Where did my mouse go? There it is. Wow. Alright, so let's do that up here. We're going to do comparison. And we're going to actually have 2, so let's just do this. And then we're going to have 2 assignments. One for if I is IW or W0 is greater or less than the tool that LinuxCNC wants it to go to. So let's hook these together. Let's do one of them and kind of play around with it. So we're gonna go into the, oops, let's first connect both of these so we have it. Oops. Okay. Oops, let's modify it though. So we're gonna say I percent W0 percent IW0 is greater than percent W0. Alright. Then let's think about this. We're gonna change this timer length. So if it's 1, it's just gonna be 22. Like if we said LinuxCNC wants to go to tool number 2, that's a difference of 1. It's just gonna go 2.2 seconds ahead. But if this is going to tool 3, then it's going to be 22 plus 18. If this is going to tool 4, then it'd be 22 plus 18 plus 18. You see what I'm doing here? So let's do a little math. Oh, we have to figure out how do we set the default value of this. What's the variable? Oops, not that. Let's look at the... So we have an IEC timer. Timer preset is TM, the number, and P. Alright, so we're going to go to, we're at the assignment. So this is timer 0. We're going to say equals 22, right? Plus percent IW0 minus percent percent W0. Except we're always starting with 1. So we actually have to subtract 1 from this math. Whoops, 1. Right? Because so if it's from 1 to 2, we're only going 1 position. So we're going to have 2 minus 1, which is 1, but we already have 1. So we're going to subtract 1 from this math. And then multiply this times 18. 1.8 seconds. Alright, so let's try this. So as of right now, we're gonna set this to 2. So this should only go one position. So you see IW0 is 2. If we say that only went 1. Oh yeah, that's right. Because the difference between these two tools is 1 position. Oh my god. Alright, so let's see what happens when we go to 3. So that should be 2 positions. You see IW0 is 3. So that should be 2 positions. 1, 2. Hey, look at that. Now this isn't like absolute positioning yet, because we haven't got that far. But this is just seeing if the timer will work correctly. So the maximum we'd ever go is, oops, we can't change it there, is to tool 6. From tool 1 to tool 6, which would be 5 positions. So this should be, this mark should be back here. So let's give that a try. Yeah, that works. All right. So how do we do the other direction? Well, let's think about that. So let's set this back to tool 1 for now. And so now this comparison isn't true anymore. So let's think about this comparison. So if percent IW0 is less than percent W0. So let's think about this for a second. When would this situation happen? This situation would happen if we were at tool 2. Remember, this can only go this direction. We're at tool 2 and we call tool 1. Alright? So now we have to go all the way around to tool 1. So that would be another 5 position run. So how would we do that in math? Well, let's think about that. So we're gonna hit OK here. Oops. And that's why you hit apply after you do this, because you'll lose stuff or it won't change to what you think. Percent IW0 is less than percent W0, or hit enter. So now that's in here. So how are we going to do this math? Let's think about this. We're going to say percent TM0 dot P equals, so we're going to have to do a whole rotation. So it's going to be 6 minus percent W0 minus percent IW0. Alright, but we're going to start with 22 plus, but we're going to have to actually subtract 1 from this one too, because we already have 1 position. You know, this is kind of weird, but let's just make sure that we aren't times 18. Let's copy this in case it errors. Hey, that worked. So if we hit OK here, so if we set this to -1, oh, that one's true. Granted, we wouldn't have a -1 tool, but that's just to see if the logic works. Alright, so at this point we have to think, okay, we have to set the tool number within ladder, this W0, after a successful change. This is where we're starting to have ladder keep track of what tool it thinks it's at. Alright, so how are we going to do that? Well, first we have to add a little more logic here. LinuxCNC does a lot of like loop back type control. So when it calls for a tool, it'll say change the tool, and then it'll wait for the is the tool changed loop from whatever logic you have happening. So we kind of have some of it, but we still need to take into account the amount of time that it takes to get back to the PAL. So if you notice this, I set this. We're gonna have to set the timer for the manual run also. So let's do that first. Let's set the manual jog so it runs just one tool rotation instead of it doing whatever it was the last one that the last timer setting that was run. So we're just going to do another assignment here, but using the B0 to trigger it. So let's see if that works. Let's put it right here. We're going to do this, but it's going to be B0. And we'll probably change this to an input at some point, but for now it's just for testing. And then we're going to have an assignment over here that says, oh shoot. So if you make a mistake like this, you can just cancel and start over. A little token of knowledge there. And B0 and an assignment. We're going to switch back to this, and I'm just going to copy this so I don't have to type it all in. We're going to put it right here. We don't need the plus. Okay. Well, also we need to connect those two. So now when we jog it, it should, whoops, I didn't hit OK. Let's try that again. Enter. Okay. So let's save this too. Seems how we're a ways into it. So now it should only go one tool location forward, hopefully. Hey. Okay. Alright, so now what we do need is we need another timer that takes into account the amount of time that it takes for the motor to reverse into the PAL. So we're just going to do another timer. I'm kind of freewheeling this here because I'm doing this a little different than I did the previous time. So don't be afraid to change things as you're doing this and see what happens. But we're going to do another timer that's triggered by this output, Q0, that then runs for like a second maybe. We'll have to kind of see what it looks like. But let's add another rung here. This is going to be controlled by Q0. And put a timer, and then we're going to do an output. We're gonna do a B2. Whoops. B2. And I want to play with this a little because I don't think I want to. Let's try a T on, and we'll set this to. Let's do hundreds of milliseconds so we have a little control, and say 1 second. I just want to see what this does. So if we hit OK. Is this what we want? Let's run this forward. No, that's not what we want. And so how about T off? No. Oh, that might work. Let's change this logic here. Hold on. This is me just fiddling. So we want to change this to normally closed. Okay. Okay. So what we want this to do is, okay, so once the tool change is initialized by LinuxCNC, we then want this to run for the amount of time it needs to do, and then we want this one to run for the amount of time that it needs to back into the PAL. So we take into account the whole amount of time that the tool change takes. So does this look plausible? No. But we still can try. We can still try T on again because we reversed the logic. Okay. That looks plausible. So the output only comes on after the total tool change is done. Does that make sense? And that sounds about like the right amount of time to me. Like I hear this stop and then the output turns on. But again, this is all adjustable, so it is what it is. I think that might work. Alright, so what do we want to do at that point? We want to set, once this happens, we want to do the loop back to LinuxCNC saying the tool change has happened. But we also want to set W1 to whatever W2 is. Or, sorry, W0 to whatever what IW0 is. So why don't we do that? Let's do this in a new thing here. So we have some space. I don't know if we have to. We might have to add some context to this yet. So so let's modify this, and we're gonna say on the rising edge of B2, right? We are going to set the tool number. So %W0, W0, oh my goodness, W0 equals %I W0. Okay. Oh, I didn't hit OK. God damn it. Trials and tribulations of ladder in LinuxCNC equals %I W0. Enter. All right. All right. So should we also do the loop in LinuxCNC? It's kind of all gonna have to happen, isn't it? So let's do this. Let's do this where... Alright, let's take a look at LinuxCNC. Show pin IO. Now IO control is the tool changing control. So I think in the bits I need, the three things I need from here is, this is the change and changed. And so this is what, you know, when LinuxCNC says, hey, change the tool, this goes high, and then it waits for this to go high, the changed, to say that the tool change is done. And then you can see this is all already hooked up, but it's hooked up to the manual tool change pop-up, so we're not going to use that. And then the prep number is the number we want to send to ladder. So why don't we set up the pins and then we can fiddle with it. Sound like a plan? Alright, so we need to unhook these. So let's go IO unlink P, IO control, tool, change, and then we want to unlink changed. And we also want to unlink the tool number because we already created a next tool number signal that we want to connect that to. So tool prep number. Alright, so let's look at the HAL file. And so tool changed, and tool number, we don't want those lines because we're going to redo those. Okay, and so this one is this next tool. We want to actually connect that to this prep number. Copy. But we're going to do it in HAL manually. We're going to say net next tool to IO control tool prep number. Alright, you see it went to 0 because currently it's 0, which makes sense. And so then we have to hook these IO control pins up. So let's do that. Let's do net change tool change, and we're going to connect that to IO control tool change to classic in. So we aren't using any ins right now, so let's use in 0. Does that make sense? And then net tool changed IO tool changed to classic out. So we already used 0, 0 to control this bit, so we're going to use out 1. So these are the two lines we need in HAL, so that when we close out of HAL, or we close out of LinuxCNC and relaunch it, these are already hooked up and we don't have to do it manually. Copy. So the other thing that I hadn't showed you yet, let's save this. Let's turn, we got to remember, so this is going to be a momentary button. It's never going to stay on. So we got to remember to shut that off. If we leave it on, it's going to screw up this whole logic. Because it's going to be a button, like a one-shot, within LinuxCNC or within ladder here. But for now, we're just, you know, fiddling. Alright, so where was I? Oh, I was going to show you... If you look at symbols... Oh. I could have swore this showed you what HAL things were connected. Okay, so maybe that doesn't do what I thought. Okay, then never mind. I wonder why that is. I could have swore symbols showed... Unless that doesn't work unless it's a clean load? Maybe that's it. I wonder if I... Should I do this? Oops. Alright, sorry. I have to do this over again. Alright. So, bring up the editor. Let's bring up the vars and... Okay, so here's the bits. Here's, and we want to change this to IW. And this was just to see if, okay, so that's set to 1, just to see if symbols work. Huh, okay, never mind. Unless you have to exit LinuxCNC and relaunch it. We'll try that when we're done. But this should give you what variable and what HAL component, or what HAL is connected to, which kind of gives you an idea. Anyway, okay, so where were we? I kind of lost track. Okay, so we hooked up the tool change to classicladder in. So that's gonna initiate the tool change. So it's going to be, instead of this, B0. Well, instead of with B0, because we want either or to do it. So let's bring up the editor and start hooking this stuff up. So we're going to modify this and we're going to add, and this is going to be, that's going to be I0, right? Okay. And that's going to be down here. And then we're going to go derp, derp, derp. And I might have to put more logic in here. I don't know yet. Alright. So when LinuxCNC says change the tool, this will start doing things. Alright. And some of this stuff we're going to probably have to... Like maybe we want to put this here also, so these don't happen when the tool chain. These comparisons only happen when the tool change is happening, which would make sense. So like we could go up to this one, to this, and say modify and add I0 and I0. So now these comparisons only actually happen when the tool change is initiated. And we could do that here because we don't want this assignment to happen. Actually, we probably do. I don't know, we'll have to see. Again, this is all stuff we can keep modifying to make it work the way we want it to. So down here, we are going to then do the loop back, which was Q1, because we hooked it up to classicladder out 1. So this will be the loop back to LinuxCNC saying the tool change happened. Alright, so We're going to modify this. We're going to do it down here because I don't know how much. So this is Q1. And when do we want this to happen? We want it to happen when I1 is high, right? And B2, I don't know if this is going to work. B2 is also high, and well, let's try that. And Q1 is low. Is that what we want? Let's Q1 is low. I'm just trying to make sure because ladder is a little funny. Alright, so Q1 is low, so that's true. B2 is high, but that'll go low when it moves. And IO needs to be high. Holy crap. So is this gonna run just the way it is? Let's bring up LinuxCNC. I don't have that running right. Alright, so we're gonna power this up. We're gonna home both axes. Now we can go in, and right now it doesn't say there's any tool in there. Let's look at this watch window. Okay, that's plausible. It thinks it's at tool 1. Let's jog this. Let's see if jogging it causes an issue with anything, for starters. Sound like a plan? I don't know why I have that. Where's the bit window? Okay. Alright, so let's jog this to this mark here. So we're going to call that tool 1. Alright, so let's undo this, or that's going to screw stuff up. So we're going to tell LinuxCNC that that is tool 1, and this would be done with the button that jogs it. Alright, so now LinuxCNC thinks tool 1 is in the position. Alright, well, let's just put this on. Huh? So that's tool 1. And we could actually put the screw in. So there's tool 1. So let's see if we can go to tool 2 and see what happens. LinuxCNC thinks tool is in, and ladder thinks tool 2 is where it's at. Holy crap. Let's go to tool 4. Holy crap. Do we want to try tool 3 and see if the reverse works? This has always been the one that is the scary one here. Tool 3. So here's tool 3. That should end up here. Holy crap, ship it. We're done. No? Oh crap, my camera hasn't been working, has it? Son of a bitch. Okay. Alright, so well, the ladder all worked. Let me look here. Jeez, I'm really sorry about that. So here's, hey, it's working. So if you look in LinuxCNC, you can see it says tool 3 is up and tool 3 is up here. So let's change this to let's go to tool 4. And that worked. So now let's go to tool 2. So that would be the other logic over here, you see. Well, that looks pretty good. So the test would be, well, let's just do this test where we jog this manually and then set LinuxCNC to tool 1. And then we'll exit LinuxC and start it back up again and see if it all works. Holy crap. Alright, so now we'll tell LinuxCNC that tool 1, because currently it thinks tool 2 is in there, that tool 1 is currently up, and then you see ladder thinks tool 1 is up too. So now if we go to tool, let's go to tool 6. Do we have 6 up here? It should go all the way around. Ah. So remember me telling you about how this needs to be a single push button? Oh, that just screwed it all up. But we can fix this because we can say tool 1 is in the tool 1 spot. So this should work. So now let's go to tool 6. There we go. Holy crap. So it fails gracefully, it looks like. But again, the manual needs to be a momentary contact. So we could we actually do that within ladder? Should we try that? Could we do that? Let's not worry about that right now. So should we go to tool 5? That should go all the way around too. So I think, I mean, this basic logic is working. So let's exit, let's save this, and let's exit out of LinuxCNC. Alright, so let's launch it again and see if it just works. Alright, so we're going to have to bring up ladder because we have no way of manually jogging it yet. What was I doing? Ladder. And really all we want is the vars up. And we're gonna jog this around until tool 1 is up. Alright, tool 1 is up. We're gonna say tool 1 is in the turret. And now we should be able to just go wherever. Tool 2. So if we do tool 2 again, it shouldn't do anything because we already went to tool 2. It should be smart that way. Tool 3, tool 2, so I think that's pretty good. Like, I'm sorry that the video didn't work, and really you didn't really miss much because that was mostly ladder work, and now you saw the finish of it. And hopefully you can kind of follow through and see kind of the logic behind how how I did this. And maybe if you guys are interested, I could make a video of putting the side buttons to do the jogging of the turret. So again, sorry about the video, but honestly you didn't really miss much because it was just me jogging it around to get the timing down for the tool change loop. So okay, talk to you guys later.